Hello and welcome to this third video of deploying cloud security connectors and high availability for servers and virtual desktops on Azure Cloud using availability sets. The first video was the introduction of and the requirements and challenge. The second was a detail about the prerequisites, what we need to have configured on the Azure portal and on Zscaler console. Also, we create a small Ubuntu machine that we are going to run an automation script. Now it's time to start the deployment of the cloud connectors. The first what we are going to do is on our Azure portal to go to the template section. You type template, I have it here. We can deploy directly the template, but you can create one. Is up to you. We can do a custom deployment and say will be your own. With here, and we have the template on the bottom of the page here. Is this template the JSON file? Simply delete it. Open it with your text editor, Control A, Control C, and we can use now here. Or you can upload the file if you want. This is the template. You can save. And now we are ready to deploy. In this particular case, we are doing the deployment on CSC East. The deployment is an availability set. This is my default domains and update domains. I'm going to deploy 4. I will put the name CSC AV, whatever. Availability set. This template will add 1, 2, 3, 4 at the end of each PM. The username is CSC admin. The authentication type will be public keys. And my public key is here on my file. It's my public key. So first I'm going to deploy the HA part. Let's call CSC HA pair. The VM size is the standard V1S. You don't need to use anything else. That's fine. Now I need to obtain the data of where to place the connector. Remember this is the VNet, and we have the external interface, the external subnet, and the internal subnet. Then it's very easy here. I will go to my VNet, and I can get the information from here. Then the first and the custom deployment is VNet name. This is the VNet name. Resource group of the VNet. Here. External subnet is on these subnets. Put the name. External is the CSC external is US. CSC external. And the internal is internal. And that's it. This is the only click agree and purchase. And this is deploy the CSC HA part on this resource group. I will stop. This can take a while, and I will back when ready to deploy the CSC pool. Okay, now the deployment was executed, and we have here the connectors for the HA pair. Then coming back again to the templates, we can deploy the template again. We can load the file. Desktop, how many crap I have here. Okay, save. And the resource group will be the same in my case. The availability set, I will put in another availability set here. We'll put CSC pool availability set. For VMs in the pool, I will call this CSC pool. The user is always CSC admin. I will put the key. Storage, whatever you want to put. The VNet name, again the same VNet that before. This is my VNet, exactly the same. Here I am. Resource group of the VNet. External subnet name. CSC external. As you can see, it's very easy to deploy this. We try to automate as much as possible, and we are going to automate more in the next release of this. And now agree and purchase. And this will take a while. Then again, I will pause this video and I will back to you when ready. Okay, we are back. The deployment was done, and now I have the VMs for the pool and the resources for the HA pair. Going back to here to the guide, I say go to template, deploy 2 for each pair, 2 for CSC pool. Security, choose your primary secondary Zscaler node. One of the ways to check and create a network security group and associate the group with the external subnet. This is a security measure to say that the connector can go direct only to the Zscaler node and will not be able to go to any one other places. All other places will go via this firewall. We have a route that is obligating this to say only these destinations will go to be direct, but the rest of destinations will go via the firewall. In addition to this, we are going to add a security group as well. Then let's take a look of a security group for this, and I will choose any one of this, and let's create a network security groups. Then let's go for the resource first. Let me go to the resource groups where the subnets are. All the subnets are here on this resource group of network. Then on this resource group, I will add a network security group. And I will create one. Again, the resource groups in one region. Oh my God. Someone should explain me why it's not selecting the same resource group. And the name, and I prepare for the resource group here. For security group, I will put this name. And I will create it. Okay. By default, the security group has blocked in inbound everything, right, except virtual network or load balancers, but it's denying all traffic. In the outbound direction is um, in this case is denying all of bound here, but there is a rule that allows any to internet, right? And this rule is allowing to any destination. What we are going to do is in outbound to add a couple of rules to select our nodes. And on selecting our nodes, one of the best way to do it is to from the machine I'm using, the small Ubuntu machine, the machine inside the region, I do an NS lookup, NS lookup of VPN Zscaler 3, and it's returning to me this IP 165.225.8, and an NS lookup to the secondary as well, and it's returning this 38. If I take a look here on the Zscaler IPS, Zscaler3.net, my primary destination is the resolution of this host name, Washington, and number 8. On New York, and the other one is New York 38, and it's resolving this one. Then these are my two IPs to that the nearest nodes. Then I'm going to use Washington as primary and New York as secondary, and these IPs. Then going back to my network security groups, I will allow in outbound that destinations only. Then source any. On destination, I will put IP addresses. Again, I have here on my documentation the IPs. This is the IPs of the nodes. Destination ports, UDP 400, 500 and 400, 4500. This is UDP traffic. I will allow, and the name of the rule is allow IPsec to Zscaler. I will wait a little bit. I will add another one here. Source any, now destination the same, but this is for destination IP addresses. Destination port is any, traffico is ICMP, and the name of the rule is allow ping, is allow ICMP to Zscaler. The next one I'm going to add now here is for the bypass proxy, that is allow port 43 to any destination. This will be via the route. The route will catch this traffic. I will send via the firewall. Then any port TCP 80 and 443. It's for bypass traffic. Any destination TCP allowed, and this is allow bypass via firewall. Okay. And finally, I will create a default block rule on the bottom that will say any protocol, any port deny. I will put on the bottom and say default block rule. Any deny. Okay, with this we allow port IPsec and ping to the Zscaler nodes. This will go direct, and this traffic will go via the firewall, and anything else is blocked. Then we have now the security group. Then we need to associate to the external subnet. We have this group. We need to come here and to associate to the external subnet. Okay. That's it. Now my next is to my browser is okay. Some Windows is catching my browse. Mine is associated. Now my next is to create a routing table for the external subnet and to reach the send nodes via Internet Next Hub and the rest via the firewall. Then if I come to my routing tables, I have a group for routing tables here. This is already created. This routing table, this one, is the default routing table. It's a virtual appliance and it's going via the firewall. Then what happened here for this subnet is all traffic by default is via the firewall. Now, if I let's discard this. Let's go back here. If I come to this overview, then I have two additional routes to the Zscaler destinations that go via internet. This traffic will go direct, and each one will use their own IP, public IP, to go out. Remember that to be load balanced in the cloud, each tunnel must be with its own public IP. That's the reason why we are not going via the firewall. We need to go direct. Each connector with its own public IP will guarantee that will hit a different instance on the cloud. That's it. And the last one, some housekeeping. Disassociate and delete the bypass public IP. For the bypass, the connector by default, when you deploy alone, it has two public IP interfaces. One is for the tunnel and the other is for the bypass traffic. In this case, we are not going to use the bypass traffic IP. We are going to send this via the firewall. Then we can delete the public IPs. Then we can go to public IP addresses here. Let's go to the location and where we are. That is US. Okay, and all these public IPs, the 01, like these ones, we can disassociate. This all ending in 01. Let me review the documentation again. Yes, all ending in 01. We can disassociate, and I will do this. Yes, we come here, disassociate. Yes, I will come here, disassociate. Yes, come here. Here and disassociate. Yes, we don't need that IPs. Okay, I will wait this to finish. I will pause in case it takes time. Well, the stuff as work was done. Now if I go to the resource group, I can filter by name, say 01. All these public IPs can be deleted. Okay. And this is the end of this video. We have completed the routing table to the Zscaler destinations. We have the security group allowing to go to the internet only to these destinations, and we have all the devices on the group. We have all the connectors ready and working. If we go to virtual machine on this location, we have the pool and the pair running, and then our next task is to start configuring each one. Thank you very much. See you in the next video.